want to deluge activated.
T-minus 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Confirm lift off.
HVB discharge now.
Stage 1 propulsion is nominal.
Entering burnout detect mode.
Crank chevron 1.
At T plus 1 minute and Electron is in the air and onward to the moon for the Capstone mission. That rocket is soaring through this nighttime sky, now past 14 kilometers in altitude in these past few moments. Now things look to be continuing nominally, which means that shortly Electron will come up against max Q, or maximum dynamic pressure. Now this is the moment when Electron will experience its most amount of mechanical stress as it travels through the atmosphere. And I can confirm from Mission Control that we have had max Q confirmed, so that was a successful pass through that milestone, and Electron is onward to low Earth orbit. So propulsion appears nominal on that first stage, and the Photon lunar upper stage and Capstone spacecraft remain healthy inside the rocket's fairing. We are coming up soon on 3 events in the launch timeline that will occur in very short succession. So soon, the 9 Rutherford engines powering Electron right now will diminish their power and then shut off completely. That command is signaled by the rocket's flight computer and then called across Mission Control comms as MECO, or main engine cutoff. Now, once that action is complete, Electron will separate its first and second stages. The main booster will continue to slow and remain behind while the second stage carries on with the mission with the ignition of its single Rutherford engine. And we have had MECO confirmed, and will be coming up soon on the fairing separation for the mission. So just to confirm from Mission Control comms, we have had MECO and second stage separation, and it's carrying on now, as you can see in that animation. So soon we will be coming up to the fairing separation of this mission. That is the jettison of the fairing halves, or the rocket's nose cone that sits on top of the second stage. So now that Electron is well past the Kármán line, we don't need that fairing. It served its purpose to protect the payload and the Photon upper stage during the launch through Earth's atmosphere. So again, that fairing will separate shortly in preparation for the final stage separation between the second stage and Photon.
Separation.
So there we go, we heard it on comms. We have had fairing separation on that second stage, and so there's confirmation that mission is continuing as it should, with Capstone and the Photon lunar upper stage now exposed to space and no longer needing that protection through Earth's atmosphere. Now, it's very exciting to see this mission up and in the air, and if you have just joined us, we have had a great start to today's journey to the moon. We have successfully cleared the pad at Launch Complex 1 just a few moments ago, and we are now well on our way to space, having completed that first successful pass through max Q, main engine cutoff, stage separation, and fairing jettison to reach this point now in the mission. Now, Electron's second stage remains attached to the Photon lunar upper stage carrying Capstone, providing it with that assist to the mission's parking orbit at 165 kilometers above Earth. The rocket's second stage is moving along nicely on its continued ascent, now traveling at a very fast speed of more than 9,000 kilometers an hour. Soon, the second stage on the Electron rocket, which is powered by our vacuum-optimized Rutherford engine, soon the batteries on that engine will need to be swapped out. Now, this is a unique aspect of our 3D printed engines because it's not many engines that are powered by batteries in the first place. In fact, the Rutherford became the first rocket engine in the world to reach space using an electric pump bead cycle when it was first launched all those years ago. Now, how it works is that we keep the engine firing all the way to orbit with the batteries that are powering that engine. But like all batteries do, these ones get depleted of power and we'll need to swap them out with a new set to keep the system running. We call that a battery hot swap, and that moment is coming up shortly. We will hopefully hear that
propulsion is
on
holding
mission
nominal.
control comms.
Stage 2 is starting to throttle down. Stage 2 guidance remains nominal, 200 seconds remaining.
If we take a look at the graphics on the right-hand side of our screen, we can see the measurements for the propellant on Electron. So on your left, you have the kerosene propellant and the level of the tanks that it is now at. So we're at 45% and counting, sitting at a nice and warm 8 degrees in temperature.
Coming up
And that
on
is
battery
very
hot
warm
swap.
compared to the liquid oxygen temperature, our other propellant. So that is sitting at a nice and chilly minus
Battery
178
holding nominal.
degrees with 40% or so propellant left.
Hot swap.
And there we have the call
Stage
that
two
battery hot
propulsion is
swap
holding
on the
nominal.
second stage was successful. Now, next we should expect to hear one of our operators in mission control call out that Electron is orbital, indicating that the rocket is in the right place ahead of stage separation. So SECO, the acronym for Second Engine Cutoff, and the subsequent stage separation follow relatively the same procedure as main engine cutoff, where the Rutherford engine on the second stage will shut off ahead of the final separation of the vehicle between the second stage and the Photon lunar upper stage. There will be a bit of a gap between that final separation and the first Hypercurie burn, as this stage separation places the Photon lunar upper stage in an elliptical orbit of Earth first. Now, a reminder that 165 low Earth orbit is just the first orbital phase for this Capstone mission, with Photon and Capstone's orbit continuously raised higher and higher over the next few days, with a series of engine burns on the upper stage. I'll go into more detail about Photon's phasing orbits and Capstone's path to the moon shortly, once Electron has completed SECO and stage separation. Let's listen into mission control comms.
Entering burnout detect mode.
So a quick check on the speed and altitude of this
Guidance is
mission.
internal,
We are
25
traveling at more
seconds
than
remaining.
23,000 kilometers an hour. And while on the right you can see the altitude is at 175 kilometers, what goes up must come down, and we will lower ourselves into that 165 kilometer parking orbit very soon.
SECO confirmed.
So with the Rutherford engine cooling down, that tells us that second engine cutoff was successful on Electron's second stage. And the Photon lunar upper stage has now departed into its low Earth orbit with the moon-bound Capstone spacecraft on board. Now, as a reminder from here, Photon is in charge of the mission. With its relightable Hypercurie engine, Photon will begin maneuvering into a parking orbit just above substantial atmospheric drag, but below the Van Allen radiation belts. It is the perfect, stable platform from which to prepare for lunar departure. Now, once Photon is in the correct orbital alignment, the Hypercurie engine will ignite again, performing a burn to lift the highest point of Photon's orbit, the apogee. Now, as it gains altitude and also loses velocity, and so what goes up comes back down as Earth's gravity pulls it back towards the planet. When it reaches the lowest point, or perigee, once again Photon's Hypercurie engine ignites to increase velocity and raise its apogee higher. So if you've ever been on a swing set, swung to the top, came back down, and then kicked your legs out to throw your weight forward to reach even higher on the next swing, then you've followed similar principles to what our Photon upper stage will be doing in space. Now, as these phasing orbits get bigger, they take longer to complete. The first will only take around 90 minutes, while the last one will take around 15 hours. Then on the final phasing pass, Photon will ignite Hypercurie for a precision translunar injection burn, accelerating the upper stage and Capstone to a top speed of nearly 11 kilometers per second, fast enough to break free of low Earth orbit on its way to the moon. The speed Photon is traveling at this point will shoot it well past the moon's orbit and to the edge of the Earth-Moon system on a transfer orbit. Lined up with the sun and using its gravitational pull to shape Photon's orbit to match speed with the moon, Capstone will then be deployed and carry on the mission solo. And so with those first few Hypercurie burns scheduled in the coming hours, I'm going to send it back to Daryl and the team at the Kennedy Space Center. Daryl, I know you weren't here in person, but how was that for you guys over at KSC? My heart is still pounding. I know our team is thrilled at this successful